So there are three types of motion: translatory motion, oscillatory motion, and circular motion. Translatory motion is the one where the object moves in a straight line. So if the object moves in a straight line, then every point of an object has the same velocity. Okay? Every point on the object has the same velocity. Every point on the object moves with the same velocity v. If the object is moving with some velocity v and object is moving in a straight line, it is undergoing translatory motion. Then every point on the object is moving with the same velocity v. You can write this in your notebook. And in an oscillatory motion is a periodic motion, to and fro motion of a particle along the same path about a fixed point. You can see this bob and a string, right? It is fixed at one position. यहाँ से fixed है वो, and it is oscillating like this. So it is oscillating about this fixed point, है ना? And it is moving along the same path to and fro. ठीक है? So it's called oscillatory motion. And circular motion. See, if the object moves in a circle along the circumference of the circle, it is called circular motion. Clear? You can write the definitions in your notebook. Please write the topics we are doing. Karo, likho. Yes, keywords. Okay? The motion of a particle along the circumference of the circle. Okay? Along the circumference of the circle is called circular motion. So what do you know about circular motion? You have read circular motion in class 9 as well, right? What do you know about circular motion? When an object moves in a circle, then its direction changes at every point. Okay? And there are two types of circular motion. One is uniform circular motion. You have read uniform circular motion in grade 9. And second is non-uniform circular motion. Uniform circular motion, the word uniform motion is the motion where the object moves with constant speed. Uniform motion is the motion where the object covers equal distance in equal intervals of time. It moves with a constant speed. And if we are saying that object is moving with uniform circular motion, so we have two different types of motion here. One is uniform motion and second is circular motion. Okay. So uniform motion is the one where the speed is constant. And circular motion is the one where the object moves in a circle along the circumference of the circle. So if the object moves in a circle with constant speed, then it becomes uniform circular motion. But if the speed is variable, if the object moves in a circle with variable speed, and then it is called non-uniform circular motion. Sometimes, we write like this. It is also abbreviated uniform circular motion as UCM, and non-uniform circular motion is abbreviated as non-UCM. Okay, we write UCM for uniform circular motion. Clear? Now, uniform circular motion में क्या होता है? Object moves with a constant speed as discussed. For example, revolution of moon around the earth. When moon revolves around the earth, it moves with a constant speed around. Okay, its direction changes at every point, but its speed is constant. And non-uniform circular motion is the one where the object moves along the circumference of a circle with variable speed. If the speed is different at different points along the circumference of the circle, then it is called non-uniform circular motion. Okay, for example, giant wheel. Okay, this is an example of non-uniform circular motion. Please write this. Next, we have questions based on this. The motion of a particle along the circumference of a circle with constant speed is called uniform circular motion. Next question. The motion of a particle along the circumference of a circle with changing speed is called non-uniform circular motion. Okay. If the particle moves with variable speed, then it is non-uniform, or changing speed, then it is non-uniform circular motion. motion of an object along a straight line is called translatory or linear motion, we can say. Next, we have radius vector. Next heading, write the heading, radius vector. See, in circular motion, the vector drawn from the center of the circle to the instantaneous position of the particle is called radius vector. If an object is moving in a circle, then we have object is at different positions in different intervals of time, right? So instantaneous position means position at a point of time. At a point of time, the position of the object. Okay? So if the object is at this position at a point of time, and from the center, if we draw a position vector, then that position vector is called radius vector. So we can consider O as the origin, and the position of the particle is on the circumference. We can draw a vector, the position vector from the origin to the circumference, the point on the circumference. It's called position vector. So O is the center of the circle of radius r, and this is the particle which is at position P1. Okay, and this particle is moving along the circumference of the circle, and this vector is called radius vector. So R1 is the radius vector. And if this particle goes to another point, and the point is P2, the new location of the particle, the new position of the particle is P2, then its position vector from the center of the circle is, let's say, R2. So R2 is also the radius vector, because we know that the radius is fixed. How do we define a circle? ऐसे ऐसे और कैसे बहुत सारे points होते हैं, collection of all the points, or we can say locus of all the points which are at a fixed distance from a fixed point. Locus of all the points, collection of all the points which are at a fixed distance from a fixed point is called a circle, right? So we know that all the points are at fixed distance, means radius, from a fixed point. Fixed point is the center of the circle. Fixed point is the center of the circle, and fixed distance is the radius of the circle, right? So R2 is also the radius vector, and now the particle moves to another point P3 after some time, and again we can measure the distance from the center of the circle. So R3 is the radius vector this time. So all the radii that we have taken, the radius vector has the constant magnitude. R1, R2, and R3 all are equal. They are equal to R. But see, magnitudes are equal, but vectors are not equal, because direction is different. So magnitudes are equal. Radius vector has constant magnitude. It has a constant magnitude. Though magnitudes are equal, but the direction in which the particular radius vector is pointing is different. So vector R1 is not equal to vector R2 is not equal to vector R3. So it is also the position vector. SI unit is meter, and dimension, because it is distance, length. Okay, so its dimension is L1. Now we have questions based on this. Dimensions of radius vector is given by, see, yes, it is a radius vector, and radius vector is also position vector. Next question. Radius vector is also known as position vector. Next we have angular displacement. Angular displacement. You have read linear displacement earlier. Linear displacement, if the object moves in a straight line, then it displaces linearly, right? And now we'll do angular displacement. If the object moves in a circle, then it covers certain angle, right, in an interval of time. So consider a circle of radius r. Particle is at A, position A, at time t equals to 0. So we're considering a situation where we have a particle and that particle is moving in a circle, and at time t equals to 0, it is at position A. Now this particle moves along the circumference of the circle and reaches point B. So B is the new location of the particle. And during this movement, it traces an angle theta. So theta is the angular displacement. Theta is the angular displacement, and the arc AB is the linear displacement. Okay. So in circular motion, the angle swept by the radius vector in a given interval of time is called angular displacement. Symbol is theta, and as we know that theta is L by R, right? We have done this formula. So S or L, whatever we write, is R theta. So theta is S by R. S is the length of arc AB. R is the radius vector, and theta is S by R. You can see both S and R, they are lengths, right? We are dividing length by length. So dimension of theta is it is dimensionless. So for very small, if we consider small displacement delta S, suppose this particle moves from B to C, very small displacement is covered by the particle and reaches point C. So for small linear displacement, we have small angular displacement, right? For small linear displacement here, if the particle moves along the circle and covers a small displacement on the circumference of along the circumference of the circle, then it covers angle swept by the particle is small, del theta. And we can write del theta as del S by R. Okay. So instantaneous angular displacement is a vector quantity. It is a vector quantity. And in vector form, we write like this. Vector S is equal to vector theta cross vector R. Okay. In vector form, we write like this. And SI unit of theta is radian. Dimension is M0, L0, T0 because it is dimensionless. And what is the direction? How do we find the direction of theta? We can find the direction by right hand thumb rule. See, how are we going to apply right hand thumb rule for finding the direction of theta? Look at this. What is this movement? Clockwise or anti-clockwise? This is anti-clockwise movement. So curling of finger is anti-clockwise and thumb points in upward direction, right? It is like this. Thumb points in upward direction and curling of finger is anti-clockwise. This is the direction of delta theta. So if the object is moving like this, then direction of delta theta, vector delta theta is upward. ये कैसे डायरेक्शन है? जो प्लेन है उसके परपेंडिकुलर. The direction of vector indicates the plane of rotation and the sense of rotation of the particle. And if it is clockwise, then what? Again apply right hand thumb rule. This time curling of finger is like this. Clockwise, thumb is pointing in downward direction. Okay. जैसे आपने पहले किया था अभी वैसे करेंगे. So this is the direction of vector del theta. So direction of angular displacement is given by which rule? We can also say right hand screw rule, or we can also say right hand palm rule. Palm ही तो है. Screw वाला Maxwell Cox screw rule किया था. ठीक है? Okay. Second, for a circular motion, the angular displacement is the angle traced by tangent in a finite time, radius vector in a finite time, radius vector in an infinite time, velocity vector. Yes, radius vector in a finite time. Next question. Unit of angular displacement is radian. क्या हुआ? Easy questions. तो हो जाएंगे, अभी आएंगे डिफिकल्ट, डोंट वरी। फोर्थ क्वेश्चन, डायमेंशंस ऑफ एंगुलर डिस्प्लेसमेंट, m0, l0, t0. Next we have angular velocity. Angular velocity is denoted by omega. Angular displacement is denoted by theta. Angular velocity is denoted by omega. How do we relate velocity and displacement? Velocity is displacement upon time. In the same way, angular velocity is angular displacement upon time. As we have v is s by t, in the same way we have omega is equal to theta by t. Okay, again consider a circle. Time rate of angular displacement is called angular velocity. See, angular displacement is a vector quantity, so is the angular velocity. Because angular displacement is a vector quantity, and when we divide angular displacement by time, then we get angular velocity, time rate of angular displacement. So this is a particle which is at position A, and it moves to point B, making an angle theta1 in time t1. Okay, particle is initially at A, it moves to point B, it makes an angle theta1 at time t1, and then it goes to point C and makes another angle theta2 in time t2. Okay, clear? Now, the magnitude omega is the average angular velocity. The magnitude omega of the average angular velocity is given by this. As we write average velocity, v as s2 minus s1 upon t2 minus t1. In the same way, we can write for average angular velocity. जैसे हम average velocity के लिए लिखते हैं ना s2 minus s1 upon t2 minus t1, ऐसे हम average angular velocity के लिए भी लिख सकते हैं. So magnitude omega of the average angular velocity is given by del omega. It is theta2 minus theta1 upon t2 minus t1. अच्छा, angular velocity constant होती है या फिर change होती है? Are you sure? Angular velocity constant होती है uniform circular motion. Because object moves with constant speed, and because object moves with constant speed, and therefore it covers equal angular displacement in equal intervals of time, and because it covers equal angular displacement in equal intervals of time, and therefore angular velocity is constant in case of uniform circular motion. Okay, now it is a vector quantity because angular displacement is a vector quantity, and therefore angular velocity is also a vector quantity. Angular displacement is measured in radian, and therefore angular velocity is measured in radian per second, because we are dividing theta by t, and only then we are getting velocity, right? Radian per second, or we can simply write per second. It is not mandatory to write radian every time. We can write per second. Per second is clear. Per second is also angular velocity, unit of angular velocity. Okay, and dimensions t minus 1, because dimension of angle is m0, l0, t0. All was 0 for angle, and therefore for angular velocity it is t minus 1. And if the particle has an angular displacement del theta in time interval del t, then we can write like this. Okay? d theta by dt. In terms of derivative, we can write. Please write this in your notebook. Linear acceleration is rate of change of velocity with time, and angular acceleration is rate of change of angular velocity with time. Okay? The rate of change of angular velocity is called angular acceleration. So again, consider the object moving in a circle. We have a particle which at point A, it goes to point B and makes an angle theta1 at the center with some angular velocity omega1, let's say. So omega1 is theta1 by t1. If time is t1, then you can write t1. And then from B to C, and velocity of the particle changes, angular velocity of the particle changes to omega2. So initially from A to B, angular velocity was omega1. So omega1 is the initial angular velocity as we had u, linear velocity, initial linear velocity, right? We had done u and v. In the same way, here we write omega 1 and omega 2. Omega 1 for initial angular velocity as we write u, and omega 2 for final angular velocity as we write v for final velocity. Clear? ठीक है, अब क्या करेंगे? The magnitude alpha of the average angular acceleration is given by this. As we write v minus u by t. So here v is replaced by omega 2 and u is replaced by omega 1 and a is replaced by alpha. Alpha is the angular acceleration. It is omega 2 minus omega 1 by t. Okay. And the quantity, what is the SI unit? What is the unit of omega? It's radian per second. And therefore unit of angular acceleration is radian per second square. So SI unit of angular acceleration is radian per second square, and dimension is this. For angular velocity, we write t minus 1. For angular acceleration, we'll write t minus 2. Or we can simply write per second square. It is not, as I have said, it is not required. Radian is not required. So you can skip radian. You can simply write per second square for angular acceleration. Okay, and per second for angular velocity. And if the angular velocity changes by equal amount in a short interval of time, the angular acceleration is given by this. Limit del t tends to 0, del omega by del t, or we can write this as d omega by dt, as we write for linear velocity and acceleration. The same way we write for angular velocity and acceleration. Okay? Any difference you have seen here? Similar है ना? एक जैसा सा ही लग रहा है ना? बस थोड़ा सा notations different है, right? Now, how do we measure direction of angular velocity and direction of angular acceleration? See, if omega is increasing with time. See, as we say that if velocity is increasing, then A is positive, है ना? And both are in the same direction. Okay, here, if omega is increasing, then alpha is in the direction of omega. If angular velocity is increasing with time, then angular acceleration is in the direction of angular velocity. Okay, both are in the same direction if omega is increasing with time. If angular velocity is increasing with time, then they both point in the same direction. But if angular velocity is decreasing with time, then angular acceleration is in the direction opposite to angular velocity. Okay? So if this is the direction of alpha, and you can see that omega and alpha, they both are pointing in the different directions. When जब आपकी angular velocity decrease हो रही है, तो angular acceleration का direction angular velocity से opposite होगा. अगर आपकी angular velocity increase हो रही है, तो angular velocity और angular acceleration same direction में point करेंगे. ठीक है? Clear? Equation of motion in rotatory motion. You have done equation of motion earlier for translatory motion. What was the first equation that you had studied? What is the first equation of motion? V is equal to u plus at. If we consider an object which is moving with some initial velocity u at time t equals to 0, and it covers some distance s and reaches at some point after some time, and its velocity changes to v, then we write first equation of motion as v equals to u plus at, and second as s is equal to ut plus half at square. Here u is omega 1, s is theta, v is omega 2, a is alpha, and what is third equation of motion? V square minus u square is equal to 2s. In the same way, we are going to write for rotational motion. Okay. So equation of motion in rotatory motion, consider a body rotating about a fixed point with some initial and final velocity. See, initial velocity we are taking as, omega, and uniform angular acceleration, because आपकी जो equations of motion आपने की थी, वो भी आपकी uniform acceleration के लिए ही थी, है ना? हम assume करते हैं कि acceleration क्या है? Constant है. तो आपने जब equations of motion की थी, v is equal to u plus at, s is equal to ut plus half at square, v square minus u square is equal to 2as, उसमें भी assume that object is moving with constant acceleration, uniform acceleration. यहाँ पे क्या होगा? Uniform angular acceleration. ठीक है, बस एंगुलर लगाते जाओ, ठीक है। तो consider a body rotating about a fixed point with initial angular velocity omega naught and uniform angular acceleration alpha. After t second, let angular displacement be theta and final angular velocity be omega. Then equation of motion can be written as this. Omega is equal to omega naught plus alpha t. This is the first equation of motion in rotatory motion. And second equation is this. As we write s is equal to ut plus half at square, the same way we are writing this. Theta is equal to omega naught t plus half alpha t square. And third equation is this. Omega square minus omega naught square is equal to 2 alpha theta. Please write this in your notebook. V के place पे we are writing omega and for u we are writing omega naught. Okay? And this is your s is equal to ut plus half at square. For in place of s we are writing theta, in place of u we are writing omega naught, for a we are writing alpha. This is how we are doing. And third equation is v square minus u square is equal to 2s. Again for v we are writing omega square, for u we are writing omega naught, and for a alpha, and for theta, for s we have theta. Okay, this is how you can compare. Okay, let's do questions. Angular acceleration is given by this, this, or this. A, both are vector. Okay. Next, the time rate of angular displacement is called as angular velocity. Next, dimensions of angular velocity. Dimensions of angular velocity. अरे थीटा बाई टी बताया था अभी, थीटा की डायमेंशंस नहीं होती, टी की डायमेंशंस होती हैं. t minus 1 ऐसे नहीं, एस ए बी सी बोलो, ठीक है. Okay, next. The angular displacement of a particle is given by this, then angular velocity at t is equal to 2 seconds is radian per second. These are the options. Find the correct answer. We'll differentiate theta with respect to t. You know how to do differentiation? किसको differentiation नहीं आता? यशिका differentiation आता है बेटा?
यस मैम, आपकी लेक्चर्स देख लिए तो उसके बाद क्लियर हो गया था.
अच्छा, उससे क्लियर हो गया. ठीक, गुड. 17. Okay, put t is equal to 2, you'll get this. 17 radian per second is the correct answer. Let's move to the next question now. Yashika, I hope you're done. Okay, we can change the slide.
यस मैम.
Okay. Next question. Starting from rest, the flywheel of a motor attains an angular velocity of 60 radians per second in 5 seconds. The angular acceleration obtained is 6 radian per second square, 12 radian per second square, 300 radian per second square, or 150 radian per second square. What is the initial angular velocity here? Initial angular velocity is 0. And final angular velocity is 60 radian per second. Time is given. Put the values and get the answer. Yes, answer is 12 radian per second square. Please write this solution in your notebook. Write the question as well. आपके एग्जाम में ऐसे क्वेश्चंस आते हैं. बेसिक है, बहुत इजी है, डिफिकल्ट नहीं है. 12 radian per second square. Okay, let's move to the next question. A stationary wheel starts rotating about its own axis at constant angular acceleration. If the wheel completes 50 rotations in first 2 seconds, then the number of rotations made by it in the next 2 seconds is. Initial angular velocity is 0. ठीक है? Time is 2 seconds. Theta is 2 pi into number of rotations. It's 100 pi radian. Okay. How will you find alpha? Theta is equal to ut, s is equal to ut plus half at square होता है ना. तो अगर आपकी इनिशियल वेलोसिटी 0 होती है तो आप s को क्या लिखते हो? हाफ at स्क्वायर. s को क्या लिखते हो? हाफ at स्क्वायर. और a को क्या लिखोगे फिर? सब कुछ वहां ले जाओगे. ऐसे ही आप, अगर आपकी इनिशियल एंगुलर वेलोसिटी 0 है तो थीटा क्या होगा? हाफ अल्फा टी स्क्वायर. थीटा इज हाफ अल्फा टी स्क्वायर. सो वी कैन फाइंड अल्फा. 2 theta by t square कर देंगे. t is given, theta is given, put the values, you'll get the value of alpha. ठीक है. उसके बाद theta in 4 seconds, half alpha t square. Find theta in 4 seconds. Find theta in the last 2 seconds. How will you find theta in last 2 seconds? माइनस कर देंगे. कैसे, किसको किससे माइनस करेंगे? थीटा इन 4 seconds माइनस थीटा इन 2 seconds, है ना. थीटा इन 4 seconds माइनस थीटा इन 2 seconds. थीटा इन 2 seconds is 100 pi. Theta in 4 seconds is 400 pi. Answer is 300 pi radian. And number of rotations 150. Write theta as 2 pi n. n क्या है? Number of rotations. ठीक है, क्लियर है ये? तो आपको यहाँ पे गिवन क्या है? 50 रोटेशंस है ना. 50 रोटेशंस के लिए we can write theta as 2 pi into 50. So it's 100 pi. Unit of theta is radian, so written radian as the unit. ठीक है. इनिशियल एंगुलर वेलोसिटी क्या है? 0 है. टाइम क्या है? 2 सेकेंड्स है. तो जैसे आप क्या करते हो कि अगर आपके पास लीनियर, इसको लीनियर से कंपेयर करो, बिकॉज अगर आप एंगुलर से डायरेक्टली करोगे कंफ्यूजन हो जाएगा, बिकॉज सब नए नए वेरिएबल्स हैं, हमें समझ नहीं आती नई चीज, क्योंकि हम एक्सेप्ट नहीं करते किसी भी नई चीज को बहुत जल्दी, है ना. हमें टाइम लगता है एक्सेप्ट करने में चेंज को, कुछ नई चीज को, राइट. लेकिन पुरानी चीजों को हम यूज टू होते हैं तो हम इजिली फ्लो में कर लेते हैं. तो आपने हमेशा जब भी इसके क्वेश्चंस करने हैं, इसको आप लीनियर वाले से कनेक्ट करके एंगुलर वाले क्वेश्चंस करोगे तो आपको थोड़ा सा क्लैरिटी रहेगी उसमें कि आप क्या कर रहे हो. जैसे आपका होता है s इज इक्वल टू ut प्लस हाफ at स्क्वायर, और अगर इनिशियल वेलोसिटी 0 है देन वी राइट s as हाफ at स्क्वायर ओनली बिकॉज u is 0. In the same way here we will write theta as, because s को हम रिप्लेस कर रहे हैं थीटा से, हाफ को हम एज इट इज लिख रहे हैं, a के प्लेस पे वी राइटिंग अल्फा एंड टी स्क्वायर. ठीक है. तो अगर आपको एंगुलर एक्सेलरेशन फाइंड करना है तो एंगुलर एक्सेलरेशन आप कैसे फाइंड करोगे? अल्फा लिखो, सब कुछ यहाँ पे, यहाँ से उठा के दूसरी साइड मूव कर दो. 2 डिनोमिनेटर में है, वहां जाके मल्टीप्लाई हो जाएगा, तो इट्स 2 थीटा बाय टी स्क्वायर. क्लियर है? We can find alpha, it's 50 pi radian per second square. Now because object is moving with uniform angular acceleration, आपका जो angular acceleration है यूनिफॉर्म है, यूनिफॉर्म alpha. Uniform angular acceleration means alpha is constant. ठीक है. तो अब we have to find number of rotations in the last 2 seconds, right? In the next 2 seconds. ये था क्वेश्चन में. नेक्स्ट 2 सेकेंड्स में क्या होंगे नंबर ऑफ रोटेशंस. तो हम ये देखते हैं कि नेक्स्ट 2 सेकेंड्स में थीटा कितना बनेगा, या है ना, पहले ये फाइंड करते हैं. तो थीटा 4 सेकेंड्स में कितना बन रहा है, तो कैसे फाइंड करोगे ये? सपोज इनिशियली आपकी ये थीटा इज इक्वल टू 0 डिग्री हो गया. इनिशियली आपका थीटा बना ये 100 पाई. ठीक है. तो 100 पाई कितने सेकेंड्स में बना? 2 सेकेंड्स में. तो 2 सेकेंड्स में जो थीटा है हमारा वो क्या हो गया? 100 पाई 2 सेकेंड्स में. अब ये कह रहा है कि नेक्स्ट 2 सेकेंड्स, मतलब टोटल नंबर ऑफ सेकेंड्स कितने हो गए? 4. 2 तो पहले ही थे, 2 और हो गए, है ना. अब 4 सेकेंड. तो 4 सेकेंड में थीटा की वैल्यू क्या होगी वो हम फाइंड कर सकते हैं. मतलब 4 सेकेंड का मतलब ये है ना. तो ये थीटा 1 ले लेते हैं, इसको थीटा 2 ले लेते हैं कि थीटा 2 जो है वो 4 सेकेंड्स में बना. तो थीटा 2 4 सेकेंड्स में बना, राइट। ये थीटा आपका हाफ अल्फा टी स्क्वायर होता है, बिकॉज इनिशियल एंगुलर वेलोसिटी तो 0 है। पुट कर दो वैल्यूज। अब टी के प्लेस पे 4 सेकेंड्स का 4 स्क्वायर कर दिया हमने, तो 16 आ गया। तो यहाँ पे 400 पाई रेडियन आ गया, मतलब थीटा 2 जो है हमारा वो 400 पाई है। ठीक है। तो अब नेक्स्ट 2 सेकेंड्स का मतलब क्या है? नेक्स्ट 2 सेकेंड्स का मतलब ये है कि इतने टाइम में थीटा की वैल्यू क्या है। इतने टाइम में थीटा क्या बना? 400 पाई माइनस 100 पाई, 300 पाई रेडियन। अगर आपका इतने टाइम में थीटा, मतलब ये नेक्स्ट 2 सेकेंड्स कह सकते हैं ना, यहाँ पे हम लिख सकते हैं नेक्स्ट 2 सेकेंड्स जो पूछा है क्वेश्चन में। ठीक है। तो इतने टाइम में थीटा कितना हुआ हमारा? 300 पाई रेडियन हो गया। ठीक है। तो अब हमें क्या फाइंड करना है? हमें नेक्स्ट 2 सेकेंड्स में थीटा नहीं फाइंड करना, हमें नेक्स्ट 2 सेकेंड्स में नंबर ऑफ रोटेशंस फाइंड करने हैं। तो नंबर ऑफ रोटेशंस क्या होते हैं? थीटा अपॉन 2 पाई। जो भी आपकी थीटा की वैल्यू आ रही है, 300 पाई आ रही है, तो आप उसको 2 पाई से डिवाइड कर दोगे तो आपके पास नंबर ऑफ रोटेशंस आ जाएंगे 150। इजी। We have a stationary wheel. It starts rotating about its own axis at an angular acceleration 5.5 radian per second square. To acquire an angular velocity 420 revolutions per minute, the number of rotations made by the wheel is. These are the options: 14, 21, 28, 35. See, angular acceleration is given, alpha is given. It's 5.5 radian per second square. Angular velocity is 420 revolutions per minute. So we need to find per second first. And how do we write omega in terms of number of rotations? Omega is again 2 pi n, but here n is number of rotations per second. Rotations, अगर आप n को कंसिडर कर रहे हो कि वो नंबर ऑफ रोटेशंस है, तो आप इसको अगर 2 पाई से मल्टीप्लाई करोगे नंबर ऑफ रोटेशंस को, तो थीटा आएगा। ठीक है। अगर आप 2 पाई से नंबर ऑफ रोटेशंस को मल्टीप्लाई करोगे तो क्या आएगा? थीटा। लेकिन अगर हम n को कंसिडर कर रहे हैं नंबर ऑफ रोटेशंस पर सेकेंड, तो अगर हम इस n को 2 पाई से मल्टीप्लाई करेंगे तो ओमेगा आएगा। ठीक है। तो डिपेंड करता है कि आपने जो n लिया है वो पर सेकेंड वाला नंबर ऑफ रोटेशंस है या सिर्फ नंबर ऑफ रोटेशन। अगर वो सिर्फ नंबर ऑफ रोटेशंस है तो थीटा आएगा। अगर वो नंबर ऑफ रोटेशंस पर सेकेंड है तो ओमेगा आएगा, क्योंकि पर सेकेंड टाइम से डिवाइड कर दिया ना आपने। पर सेकेंड मतलब आप टाइम से डिवाइड कर रहे हो, तो नंबर ऑफ रोटेशंस को आप टाइम से डिवाइड कर रहे हो, तो थीटा को आप टाइम से डिवाइड कर रहे हो, राइट। ओमेगा ही आना है ना, एंगुलर वेलोसिटी। अ स्टेशनरी व्हील स्टार्ट्स रोटेटिंग। ठीक है। तो इनिशियल एंगुलर वेलोसिटी को हम इसमें 0 ले लेते हैं। अल्फा इज 5.5 रेडियन पर सेकेंड स्क्वायर, और टू एक्वायर एन एंगुलर वेलोसिटी मतलब ओमेगा 2 या ओमेगा फाइनल वी कैन राइट, बिकॉज इनिशियल के लिए आई लिख रहे हो, इसको या तो 1 कर दो, 1 और 2 कर देते हैं। तो इनिशियल एंगुलर वेलोसिटी इज ओमेगा 1, इट इज 0, अल्फा इज 5.5 रेडियन पर सेकेंड, और टू एक्वायर एन एंगुलर वेलोसिटी 420 revolutions per minute, 420 revolutions पर मिनट। तो पहले तो फाइंड करो पर सेकंड कितने होंगे, 60 से डिवाइड करो, फिर इसको 2 पाई से मल्टीप्लाई करो। ठीक है। ठीक है ना। 420 revolutions पर मिनट दिया हुआ है ना आपको, तो आपको नंबर ऑफ revolutions पर सेकंड निकालना है। ठीक है। तो कितना आ रहा है बेटा? 145। आपका ओमेगा 2 आ रहा है। अच्छा, अब आपको क्या फाइंड करना है? नंबर ऑफ रोटेशंस मेड बाय द व्हील। नंबर ऑफ रोटेशंस मेड बाय द व्हील मतलब ये, उसके लिए क्या चाहिए? थीटा। थीटा आएगा, थीटा को 2 पाई से डिवाइड करोगे तो नंबर ऑफ रोटेशंस मेड बाय द व्हील आ जाएगा। अब थीटा कैसे आएगा? थीटा कैसे आएगा? ओमेगा 1 पता है, ओमेगा 2 पता है, अल्फा पता है, 3 इक्वेशंस पता है, कौन से वाली लगेगी? कौन से वाली लगेगी? थर्ड। सेकंड वाले में टाइम चाहिए, टाइम नहीं है हमारे पास। फर्स्ट वाले में टाइम चाहिए, नहीं है। थर्ड वाले में टाइम नहीं है, तो थर्ड इक्वेशन लगाएंगे हम यहाँ पे। ठीक है, थर्ड इक्वेशन क्या है? ओमेगा 2 स्क्वायर माइनस ओमेगा 1 स्क्वायर इज इक्वल टू 2 अल्फा थीटा। ओमेगा 1 पता है, ओमेगा 2 पता है, अल्फा पता है, थीटा निकाल लो। और थीटा को 2 पाई से डिवाइड करके नंबर ऑफ रोटेशंस फाइंड करो। ये क्वेश्चन आपने ऐसे करना है। दिस इज द इक्वेशन दैट वी आर गोइंग टू यूज, है ना? तो अब इसको हम ऐसे लिख सकते हैं। तो यहाँ पे जो N2 है, N2 क्या है? नंबर ऑफ रिवोल्यूशंस पर सेकंड। ठीक है, स्क्वायर है ना, ओमेगा 2 स्क्वायर, तो 4 पाई स्क्वायर N2 इज इक्वल, N2 स्क्वायर इज इक्वल टू 2 इंटू 5.5, एक्सेलरेशन हो गया, एंगुलर एक्सेलरेशन टू थीटा। पुट कर दो, सॉल्व करोगे तो यहाँ से अब यहाँ पे हमने क्या किया है, इसको थीटा के प्लेस पे वी हैव रिटन दिस 2 पाई n। थीटा के प्लेस पे डायरेक्टली हमने लिख दिया 2 पाई n, क्योंकि नंबर ऑफ रोटेशंस फाइंड करने हैं। थीटा इज 2 पाई n, n इज नंबर ऑफ रोटेशंस पर, नंबर ऑफ रोटेशंस ओनली, नॉट पर सेकंड। पर सेकंड इज फॉर वेलोसिटी। सॉल्व करोगे एंड यू विल गेट योर आंसर। दिस इज हाउ you have to do it.